Question number 1 on page 100, the quick check, asks about the potential energy gained by a 45 kilogram girl. Potential energy is equal to m, mass, multiplied by g, the gravitational constant, and the change in height. So it's a simple matter of plugging the numbers in. 45 times 9.8 times the change in height, 6 meters, gives us 2,646 joules. In question 2, it wants to know about the elastic potential energy of a spring in a toy gun. We know that EP is equal to 1/2 kx squared. The challenge here is that we don't know what the spring constant is, so we have to find it. We can use the fact that F is equal to kx, and we can then set EP is equal to 1/2 Fx, where F is the total force that is required. Okay? So this works out to 1.2 times 0.03 when we do that, because if the average force is the middle of the total force, we know what it is. It's told to us here. The average force is 1.2. So from this, we're going to get 0.036 joules. For part B, it wants to know how this is going to be changed into kinetic energy. Well, if I know the potential energy is 0.036, and I know it's going to be changed into kinetic energy, mv squared over 2, I know all the information I need. I know this mass is 10 grams, so by rearrangement, V is equal to the square root of 2 times 0.036 divided by the mass of 0.010 in kilograms. This gives me 2.68 meters per second. Pretty slow. And for question 3, you're supposed to know about the forms of energy. Well, if you have the basketball, it has potential energy at the top. As it falls, potential energy is transferred into kinetic energy. Just before it hits the ground, it has maximum kinetic energy and a minimum potential energy. And then as it's deformed, it gains a new form of potential energy, the elastic potential energy of the ball is stored in the deformed shape of the ball, and then when the elastic potential energy is changed back into kinetic energy, the ball will drive upward. As it drives upward, again, the kinetic energy will decrease and the potential energy will increase. It's pretty much all you have to worry about. And this is the quick check on page 101. It says how much work can a 5 horsepower motor do in 10 minutes. Work is equal to power multiplied by time. And the power of 3 horsepowers is 3,750 watts, because each horsepower is 750 watts. Multiply this by 10 minutes and 60 seconds per minute, because we need to work in seconds, and you will get 2.25 times 10 to the 6 joules of work. Question number 2 wants to know, if you have this 60 kilogram boy run up a flight of stairs in 2.6 seconds, what is his power output? Well, his power is equal to his work divided by the time, so his change in potential energy, mg delta h over change in time, is equal to his power. We have a mass, 60, we have a g, 9.8, we have a change in height of 3.32, and we have a time of 2.6. This works out to 751 watts, which is about 1 horsepower. Question number 3. How long would it take a 5 horsepower motor to lift a 500 kilogram safe? Again, power is equal to work over time, which is equal to mg delta H over time. By rearrangement, we get the time is equal to mg delta H over P. We need to work in joules, and we need to work in seconds, and we need to work in watts. So we need to do the conversion of 5 horsepower into 3,750 watts again. So for our purposes here, we're going to have the mass of 500. We're going to have 9.8. We're going to have a change in height of 30 meters. And we're going to have the power is 3,750 watts. We do all this in 39.2 seconds. 39.2 seconds. Done.